Now again we are going to adopt the information or guidelines mentioned in the IS 456 related to limit state method of design of RCC beam, and what are the design requirements for a singly reinforced RCC beam as per IS 456. So first of all, we have to understand that the design of beam which we are going to discuss here, we will be taking into consideration only flexural aspect of the beam. So design of the beam under flexure, which will be dealing with the determination of cross section dimensions of a beam section. So in this design part, we will be able to work out what is the width of the beam, what is overall depth of the beam, that is capital D, what will be the requirement of cover to reinforcement, then effective depth of the beam section. Then after going through the cross-section dimensions, that means deciding or assuming the various cross-section dimensions which we have discussed here, as well as some cover to reinforcement and the width of the section as well as the depth of the section. So depth will be overall depth, which is generally we use symbol capital D, and for effective depth we will be using symbol small d. So let us now try to understand it more clearly in this today's lecture. Then the second part of the design is tensile reinforcement. So that means what is the tensile reinforcement required in terms of area of steel, and then we will decide what will be the number of steel bars which we have to provide based on the area of steel as well as based on the diameter of the steel bar which we are going to assume in this part of design of the section. So tensile reinforcement required for ultimate movement on beam due to various load. So we are clearly aware from the last few lectures that whenever a beam is subjected to some types of loads, then due to that load, that beam will be under flexure. That means some bending moment will be acting on it, and we have to first of all calculate what is the factored bending moment, and then according to what is the ultimate moment which we are expecting that beam will be going to subject through its life period. So based on that ultimate moment, we will be going to design the requirement of tensile reinforcement. That means how much area of tensile steel is required, which can take care of all type of tensile stresses which are going to develop due to the loads, and in other sense we can say due to the movements. So in tensile reinforcement requirement, we will be able to find out what is the diameter of the steel bar which we are going to use in case of RCC beam. Then what are the number of bars required? How many number of bars of particular diameter of bar which will be required to be used as a steel reinforcement. Then we will decide what should be the spacing between two bars. That means clear spacing as well as center to center spacing of the bars which is required. So let us continue. And here we will be going to discuss in broad sense that what are the prominent steps which we will be going to follow in case of design of RCC beam in flexure. So very first step will be we have to find out what is the effective span of the beam. So why we have to find the effective span of beam? Because you know that whenever we are calculating any bending moment due to the loads, then in that particular formula most of time it will be just like WL square and with some coefficient. So what I want to say here, that whenever you are going to calculate bending moment, for which you are going to design the beam, and that bending moment will be in terms of square of the span. So that means if span is larger, then ultimately bending moment value will be increasing, and when bending moment is higher, then you need more reinforcement, as well as your section will become heavy as well as uneconomical. So that's why effective span of beam is very important part, or we can say very important parameter in the design of RCC beam. Second is concrete cover. We will discuss in detail what is the meaning of concrete cover, what is the requirement of concrete cover, and how much concrete cover we have to provide based on the guidelines mentioned in ISO 456. Then we have to work out the spacing between the reinforcing bars. That means whatever the reinforcement we are providing in the form of steel bars, so the spacing we have to decide, and based on the spacing we will be easily able to calculate what are the number of bars required, or in other sense we can first of all we will find out what is the area of steel required, and then assuming a suitable diameter of bar, we will be able to work out how many number of bars are required, and based on the number of bars we have to work out that when you are using those number of bars, then what will be the space available between those bars. So that is the spacing, and we will discuss in detail what are the codal recommendation or limits specified in IS 456 regarding the spacing between the bars. Then we will be having to discuss that minimum and maximum area of flexure reinforcement. Here code will be pointing out some limits, that means what is the minimum area of steel which we can provide, as well as what is the maximum area limit of flexure reinforcement. Later on we will be going to discuss the deflection control mechanism, that means how the deflection can be controlled in case of designing any RCC beam section. After that we will be focusing on how to get the efficient bond strength, that means how we can make the bond between the steel and concrete efficient, so that concrete and steel can act as just as a composite member, and they are able to take care of all the stresses. So in today's lecture we are going to discuss these four parameters, that means how to work out all these four parameters in the guideline or in the light of the information available in IS 456, and later on lecture 11 will be devoted to deflection control requirement, bond strength, and some other information.